In 9.6 notes, we're going to be describing distributions. So we're going to name the center, unusual points, shape, and spread of data. So the shape is going to affect how we name the center and all of the unusual points and all of that. So you have to determine if the shape of your data is symmetric or skewed. If it's symmetric, it could look like a uniform graph where everything's about the same height in this histogram. If you were to make a box plot out of this, the box plot would have an even part of whiskers and box, or everything's the same length. Or it could be bell-shaped, where most of the data is in the center with a few high and a few low around that center data. If you were to make this into a box plot, it would look the same as the uniform data. So sometimes a box plot is not that helpful in seeing the shape, where a histogram is more helpful. If you have skewed data, you can have it be skewed left or skewed right. So starting with skewed left, it means you have weird, unusual data to the left. So this number is much smaller than most of the other numbers, so this would be called skewed left. In a box plot, you'd have a longer left whisker with possibly even asterisks for the outliers. If it's skewed right, it means you have unusually high values on the right of the graph. Where most of the data is over here on the left, you have high number here on the right by itself. And then as a box plot, you have this really long right whisker. So not every set of data is going to fall and look perfectly like one of these four options, but most of the data will form some sort of pattern. Either symmetric, where when you fold it in half it matches up, or it's skewed, where you have unusual data, high or low, from the rest of the data. So depending on the shape, you're going to test for outliers differently. If it's symmetric, anything that is more than 3 standard deviations from the mean is going to be considered an outlier. And don't worry, we'll go more into detail about that in a little bit. If it's skewed, we're going to use the 1.5 rule. So you have the Q1 minus 1.5 times the IQR and Q3 plus 1.5 times the IQR. So if it's symmetric, you're using 3 standard deviations from the mean. If it's skewed left or right, you do both of these formulas to see if you have outliers. To find the center, if it's symmetric, you would use the mean, your X bar. And if it's skewed, you're going to use the median. The reason why is if you have a really high number that's all by itself, the median cancels off those really high and really low numbers, and it keeps the number in the middle. Whereas the mean, you would be adding that really high number that's by itself, so it would make the mean different. So if it's skewed, we use the median for the measure of center, and if it's symmetric, we use the mean. To name the spread, how far apart is your data? If it's symmetric, you're going to use the standard deviation. And then if it's skewed, you're going to use the range and the IQR. So when it asks you to describe the data, you're going to list the 4 things. The 4 things spell out the word socks. So S is your shape. What kind of shape is it? O for outliers. C for center. And then S for spread. So SOCS, socks. Very exciting. It says the age of presidents during their first inauguration is listed below. We're supposed to make a histogram of the data. So this is starting off with the first president, George Washington, and then this ends with Trump. So we're going to number our number line down here and start. The youngest was for like between 40 and 44, then 45 to 49, 50 to 54, 55 to 59, and so on. And then I'm going to go ahead and just plot this for you. So I'm going to count by twos. So there were 2 presidents between 40 and 44. There were 7 presidents between 45 and 49 for their first inauguration. And then there were 13 between 50 and 54. And 12 between 55 and 59. And then another 7 here between 60 and 64. and then 3 between 65 and 69, and then there was one president that was between 70 and 74. So that's making the histogram. So how would you describe the shape of this data? Is this skewed or symmetric? Well, in this case, most of the data is at the center, so this would be considered symmetric. It's not perfect, but it's a pretty symmetric graph. And I would not call this uniform because not everything is the same height. Instead, I would call this a bell shape to be more specific. So it's symmetric, but it's also a bell-shaped graph. So we're supposed to find the mean and the median. So when you type it into all this data into your calculator, your X bar is 55. And then your median, the M, is 55. Notice how these are exactly the same. That means there's no unusual values here since they are exactly the same. If your mean is a lot higher or lower than the median, that's a clue that your data is skewed. So what's the best measure for center? Well, since it's symmetric and bell-shaped and the mean and the median are the same, we would use the mean. If it was skewed, then we would use the median. So this is asking us to find the standard deviation. So when you type it into your calculator, find S of X, you get 6.6. Okay, number 2, the prices below are the current prices of homes for sale in the Hamul according to sdlookup.com. Now, to be honest, this is probably back in 2015 or so when I first started teaching pre-cal and wrote these notes, so this is a little bit outdated. But I'm going to go ahead and make a box plot of this. So we have our minimum, our quartile 1, our median, quartile 3, and our maximum. But then we have this outlier of 1,799,000. So it says to describe in detail the distribution of the data. So when it says this, it's very vague, but they're always going to be looking for the 4 things, the SOCS, socks. So let's start with the shape. Since you have an unusual value over here, we would call this skewed, and it's to the right because we have a high unusual value. Continuing to spell socks, O for outlier. Since it's skewed, your outlier has to be checked by the 2 formulas, the Q1 minus 1.5 times IQR. So quartile 1 was 399,900 minus 1.5 times the, remember the IQR is quartile 3 minus quartile 1. When you type that in, you're going to get $2,250. Notice there is no home cheaper than 305,000, so there is no minimum outlier. Now we have to check for the maximum, so you have to do the other formula, which is quartile 3 plus 1.5 times IQR. And when you type in that data, you get 1,062,650. So that does mean we do have an outlier because there is a home that's more expensive than that at 1,799,000. That's why there was an asterisk. To name the center, SOCS, socks, center, since it's skewed, we use the median. So the median is at 547,500. SOCS, the last one, is spread. When it is a skewed set of data, you don't use the standard deviation, you use the range and the IQR. So your range, you do the max minus the min, so it's 1,799,000 minus the 305, you get 1,494,000. And then your IQR is quartile 3 minus quartile 1, so you get 265,100.